Today we're going to be talking about compounds. And so with that, we're going to be looking at molecules and ionic compounds. A basic definition of a compound is groups of atoms that are bonded together or stuck together. So after today's lesson, you should be able to define molecules and ionic compounds. So we're going to look at some laws connected to how atoms combine together and how they create compounds. So here's a law called the law of definite proportions, or the law of constant composition. It's two names for the same law. The definition says all samples of a pure compound contain the same elements in the same proportion by mass. So what does this mean? Well, say you've got water in Provo, and you look at your water molecule in Provo, and you have a water molecule from Africa. If you zoom in and look at them, you'll see that they are exactly the same. The water molecule in Provo is made out of 2 hydrogen atoms and 1 oxygen atom, and the water molecule in Africa is made out of 2 hydrogen atoms and 1 oxygen atom. So here's another way of seeing that. So if we have a bunch of water together, you can see that each of these water molecules has 1 oxygen and 2 hydrogens, and they are all composed or made out of the same stuff. So the law of multiple proportions. So this law is when 2 elements react to form more than 1 compound, a fixed mass of one element will react with masses of the other element in a ratio of small whole numbers. So what does this mean? Well, it means that different types of compounds can be made out of the same type of elements or the same stuff, as long as the other compound has a different number or ratio of atoms. And so we're going to look at that. So here's 2 different types of compounds. We have water, which is H2O, and we have hydrogen peroxide, which is H2O2. You'll note that this 2 tells us that we have hydrogens, and the lack of a number here shows us that we have 1 oxygen. With our hydrogen peroxide, this 2 says there's 2 hydrogens, and this 2 after the oxygen tells us that there's 2 oxygens. If we look at models of these molecules, you will see that water has 1 oxygen and 2 hydrogens. Hydrogen peroxide has 2 oxygens and 2 hydrogens. But they have different numbers of these elements, even though they are made out of the same type of elements, because the ratios are different. Then they are different compounds and have different properties. Water is something that's very safe to drink. Hydrogen peroxide could, in high enough concentrations, burn your fingers. And so the law of multiple proportions, continuing with this concept, it also means that elements always combine in whole number ratios. So you can't have a single part of an atom, but you have to have the entire atom in a compound. And you will never have those partial atoms in any compound or molecule. So we're going to now talk about molecules. Molecules are a group of atoms that are bonded together by sharing electrons. So you can see a bunch of friends, their arms are linked together in the bonds of friendship. In a similar way, molecules are linked together. And so if you look at this, how many of each type of atom do you see? Count the number of oxygens and count the number of hydrogens. So hopefully you can see that there's 1 oxygen and that there are 2 hydrogens. And that's where our formula comes from. We look at the fact that there are 2 hydrogens, and so when we write the H, we put this 2 after it and then O. So the molecular formula H2O tells us the type of atoms and how many of each type of atom are in the molecule. What about this one? CH4. How many carbons and how many hydrogens? Here's carbon dioxide. So hopefully you can see carbon. The lack of a number in chemistry means 1. And so the carbon here, there's 1. And the 2 following the oxygen there's 2 oxygens. Table sugar, C12H22O11, means you've got 12 carbons, 22 hydrogens, and 11 oxygens. Ionic compound. An ionic compound is a group of atoms that are bonded together by opposite charges. So here's a way of thinking about ionic compounds. You can think of ionic compounds as a business deal. One person sold a product to another. This results in a net gain and loss of product. So the person selling the product lost it, the person buying the product gained it. As a result of this relationship, the two stick around each other. So people stick around ice cream trucks because they're buying ice cream. Or you would go somewhere where you're doing business. And so what ionic compounds end up doing is they have this positive and negative charged particles that stick around each other. So here's an example of an ionic compound, sodium chloride. Sodium chloride occurs when sodium gives away its extra electron to chlorine. Sodium then becomes positive and chlorine negative, so they are attracted to each other as a result, and they form an ionic bond. And so we can see here we've got positive sodium and negative chlorine. The two are bonded together. Now, one interesting thing about ionic compounds is we have what are called formula units. So here you can see sodium chloride. You can see there's a whole bunch of sodium and chlorines. And this positive sodium is going to be connected to all of these negative chlorines because they're positive and they're attracted to negative things, and negative are attracted to positive things. But if you were to break this sodium crystal into the tiniest possible piece, you would have 1 sodium ion and 1 chloride ion. And that is a formula unit. The smallest possible piece that you could break a ionic crystal or compound into and still have that compound is your formula unit. And so you can see kind of another way of modeling that here. And you can see that that opposite charge is attracting the 2 ions to each other. And that wraps it up. So hopefully now you can say that you understand what molecules and ionic compounds are. If you need to rewatch the video, please do. And keep up the great work.